Thanks very much for having us here to discuss. I'm going to talk about Azure and Kubernetes. I wanted to start with, sorry, I guess I'll first introduce myself. I'm Brendan Burns. I'm one of the 3 original founders of Kubernetes. I think we're lucky. I think we got Joe and myself both on this call. So you have well represented in the history of Kubernetes and can answer those questions if you want. I'm also the engineering lead for cloud native open source at Microsoft and Azure. And so focused really heavily on how we bring this technology to our Azure customers. I wanted to start actually because I think it's most important with how Microsoft thinks about the community. I think Kubernetes from its beginning knew that it was not about a single vendor or about a single company, but it was actually about the broader ecosystem and community that we were building. And so I think that it's really nice to start by highlighting the things that we have done. I noticed in a couple of previous talks, things like Helm being mentioned. That's a project that is primarily run by engineers committed to open source within my team. But what's really great there, I think, is that tool, despite being supported by a bunch of Microsoft engineers, is actually available to you for Kubernetes anywhere, right? It doesn't matter where you're running Kubernetes. Obviously, we can do a great job of helping people through things like the Helm 2 to 3 deprecation process because we have that engineering team in-house. But we're really committed to this notion that we build open source software for the entire world, not just for people who happen to be running things on Azure. And we believe by doing that, we're making Kubernetes on Azure better. And it includes things that we've created and donated to the CNCF, like Gatekeeper, like cloud native application bundles, virtual kubelet, and then a bunch of things spanning from how we package applications all the way through to developer productivity. But I think it's more than just software that we work on. And I think actually one of the more important things we also do is community leadership. So we're obviously on the governing boards of both the Linux Foundation and the Cloud Native Compute Foundation, the technical oversight board for the Cloud Native Compute Foundation. We have 2 of the 7 folks who bootstrapped the entirety of the Kubernetes governance, so wrote sort of the founding documents of the Kubernetes community. And we're also engaged in areas like leading SIG-Auth, where we have, helping lead, co-lead, I should say, SIG-Auth, where we have direct impact on things like Gatekeeper. But I think beyond just sort of the governance aspect, it's also really important to be doing the community service part of it. And we have people who volunteered to be the Kubernetes release lead. If you know anybody who's done it, it's an utterly thankless job, but absolutely essential. Like releases don't happen without those people. And these people have been recognized at KubeCon with things like the Chopwood and Carry Water Awards, which is, I think, a tremendous acknowledgement of their contributions to moving the community forward in honestly a selfless way. So I think that gives a good frame for how we think about the community and how we approach Kubernetes. And then I wanted to jump into the Azure Kubernetes service. I'm not going to drain this slide, but when you think about the Kubernetes service that we provide, we really think about it in 4 pillars. The managed pillar, about effectively running Kubernetes so that you don't have to. Obviously, that's things like auto-scaling, automatic fixes. The secure pillar, obviously, that's a really big deal for this customer, but honestly, customers everywhere. And includes things like making sure we have absolutely the latest Kubernetes builds, that we have actually patched our Kubernetes for day 0, so you are already up to date even before a CVE is released. But also integrating tools from Azure like Active Directory. I'll talk a little bit about that later. Building scalable clusters that can meet any need. Obviously, we have the most regions in the world of managed Kubernetes. There's another slide on that. So whether you're in public cloud or whether you're in private cloud, we have the ability to deliver, or even if you're at the edge, we have the ability to deliver Kubernetes to you in the areas that you need them for. As well as understanding the security needs of the enterprise or government customers who really need to know for sure what's going on inside of this, even as they're moving to cloud native patterns, understand what's going on in their Kubernetes clusters. But from a customer perspective, I think that the most important thing is we're taking a view of Kubernetes and really taking this over so that you can focus on delivering your applications on top of this Kubernetes running in the cloud, right? So you can sit back effectively and run your applications without having to see them deal with the intricate details of, this this version and that particular configuration. And both of Kubernetes itself, which is a large-scale distributed system, but also of the intricacies of getting it to run on a particular cloud like Azure. We understand and have connections to all of the service teams that work to deliver Azure and take care of ensuring that that platform is ready to run Kubernetes and that the Kubernetes is available to you whenever you need it. I mentioned before that we have Geodistribution that is unmatched. And this really, helps us make sure that wherever the workload needs to be, we can deliver Kubernetes. But it's not just about our data centers. And I think that's where we see Azure Stack and Azure Arc playing a significant role. So through Azure Stack, we have the ability to deliver an Azure-like native experience, so to a private air-gapped environment. Right? We can deliver that out into the field. We have hardened versions of that can ride along with people deploying out into effectively any environment anywhere, and Kubernetes comes along for that ride. We have tools like Azure Stack HCI, which allow you to deliver Kubernetes into your on-premise infrastructure with a lot of flexibility and choice around the infrastructure that you purchase. And then finally, we have Azure Arc that actually enables you to connect Kubernetes into our cloud for management, policy, and control, no matter how you choose to develop Kubernetes. So you can even take Kubernetes that's been developed by a partner or by some other company, and there's a number of them on the call today, and integrate that with Azure Arc for compliance, single pane of glass, GitOps deployments, and a bunch of other capabilities that make it easier for you to manage sort of your estate of Kubernetes, no matter where it happens to be running. I want to pivot from that sort of high-level view to a view of like what some specific capabilities. And this is obviously, I'm going to give you an eye chart exhaustive list, but I want to jump from this sort of set of things that we think about in terms of DevSecOps into some specifics about how we actually implement security and developer productivity within Kubernetes. And I wanted to jump, it's an odd thing to start with, but I wanted to jump to the VSCode extension that we've built for Kubernetes. Now this extension is like Helm. It is available to anyone, anywhere. It's an open source project out on GitHub. And the reason I want to call attention to this is actually because of this, this option. So if you view your cluster in the left-hand nav, you can actually right-click on any pod, and you get a bunch of options, and one of those options is port forwarding. Now, port forwarding is the ability to securely connect to a running pod to your local machine. And it could seem that this is a very odd thing for me to start talking about our DevSec options with, but actually it's this kind of ease of use that is the kind of thing that prevents security problems. Because, for example, recently our security folks pointed out this crypto mining that was happening because people had misconfigured their Kubernetes cluster. Now, one of the main reasons why people misconfigure and put things on the public internet that they shouldn't is that it's just the easiest way to sort of see something, right? They installed some software, they want to see it running, and just like turning up a load balancer and putting it on the internet is the easy thing that people do, or they do it accidentally. If you integrate into people's tools, into their familiar environments, the ways to do things securely, they're going to do that. Right? If I can right-click and port forward and suddenly the service is there, I don't need to put it on the public internet. I'm not even going to think about putting it on the public internet. And so, while we're going to talk a lot about policy that will actually help prevent this kind of attack also, I think it's also important that we take a comprehensive view and understand that actually a big part of security is helping people do the right thing, helping people fall into that pit of success. But taking a step forward, speaking of this specific attack, one of the other main tools that you use for this is figuring out how you can effectively prevent people from making mistakes in the first place. And I wanted to talk about how we think about securing Kubernetes resources, right? So like traditionally, you think about securing resources through RBAC, and RBAC is great, but it actually is a real gap. It leaves a big gap. And this was mentioned earlier, actually, in the intro about Gatekeeper and policy. There's all of these open questions, like where is that image from? Did you get a security review? Who are the people who are running this service? And these are critical questions, actually, for delivering a secure environment. And RBAC doesn't take care of any And so in response to that customer need, we actually went out and created the Gatekeeper project, right? And so the Gatekeeper project was an implementation of policy using a language that was already existing in the open policy framework, or open policy agent, to apply policy to Kubernetes. And it can ensure compliance around things like, being present in a private registry, that public service is only out on the public internet if you've had a security review, or maybe that no service is ever out on the public internet. Policy is the thing that actually enables you to let developers run wild on the Kubernetes cluster and still be sure that they're doing it in a safe and secure way, right? And I think this is a great illustration of how we combine open source innovation in a truly open project. Gatekeeper runs anywhere, with integrating it into Azure, because Gatekeeper is a supported part of what it means to run Kubernetes on Azure. And so that means that, yes, Gatekeeper is available to anybody, but if you use Gatekeeper in Azure, you can file support tickets, we'll help you understand it. And possibly more importantly, we have pre-cut policies for you. We have very easy to use ways that you can install policies onto your cluster. You don't have to understand the Rego policy language, which is a little bit complicated, in order to secure your cluster. And I think that's a great example of the interplay between community work and product work that we do. I wanted to also highlight another real thing that is truly critical for securing access, and that's this idea of zero privileged access, right? And so when you have a production cluster, you shouldn't have anybody who have access to it at all, right? That's the most secure environment that you can have. But of course, people need to actually make changes. People need to fix things if things go wrong. And through Azure's privilege identity management, you can actually have someone say, hey, look, I need to request to elevate my permissions, have someone approve those permissions. They get time-bound membership into the privileged access group. Now they have access to the cluster for 8 hours or whatever the time period is. And you know for sure through audit trail when they had access, when they didn't have access, who had access, and who approved, right? And so this allows you to actually produce a very secure environment. And I think it's a great example, because this privileged identity management is not a AKS feature. It's an Azure Active Directory feature that we've integrated into AKS. And so you're gaining the benefit not just of the Kubernetes and open source community and cloud native work that we do, but also all of the fantastic work that the folks over at Active Directory have done around identity management and the scenarios that you need to do that at scale. And speaking of at scale, I think one of the other things we talked about is once you have clusters running around in Humvees or running around out on airstrips, there's a real problem of scaling your DevOps. Right? And so if you have to push all of these configurations of policy and applications and everything else into each individual cluster, it can be really, really painful. And so when you think about this with Azure and with Azure Arc, we are providing abilities like GitOps built into the platform, working through Arc to Kubernetes anywhere, that enable you to actually scale this policy or really scale any kind of configuration of your cluster so that you have a single source of truth. And you push it out to the clusters everywhere. And I like to bring this up again with reflections about how we interact with open source, because at the core of this GitOps operation is this tool called Flux. And Flux is actually not a project that we created. We didn't say, hey, look, we're going to do this GitOps thing, so we have to build a new open source project. We actually went out into the community and we found a project that was already very active, very successful. And we worked with that community, and we brought it back into Azure as well as part of a supported product. But also we're working with that community going forward as we sort of work with defining GitOps within the CNCF community broadly. That's an effort where we're not just sort of donating new projects, but we're actually jumping in, lending a hand, chopping wood, carrying water, and ensuring the success of pre-existing open source technology. And again, for the broader Kubernetes community, but also as a supported part of what it means to have Kubernetes in Azure.